So for this lesson, we will be mainly focusing on the piece of operations that we did not cover in the last lesson, and that is dividing or just rationalizing denominators. So with imaginary denominators, a radical expression is in simplest form if no radicand contain fractions or radicals appear in the denominator of a fraction. So very similarly, a complex number is in simplest form if no imaginary numbers appear in the denominator of a fraction. So when you are dividing with complex numbers, you are not finished until you get your I out of the denominator. So when your denominator is a monomial, that is really simple because you just have to multiply by I over I. So when you do that here on number 1, you end up with 2i over 4i squared. And then that is equal to 2i over 4 times negative 1. And then this gives us 2i over negative 4. And that leads us to a negative I over 2. So we're going to go ahead and try this again on number 2. So we have a monomial in the denominator. So we're going to multiply by I over I. And this gives us 5i over 7i squared. And so that leaves us with 5i over 7 times negative 1. And that leaves us with negative 5i over 7. And so we have I out of the denominator, so that one's all done. So remember, a complex number is a combination of a real number and an imaginary number. So when you are dealing with it in the denominator of a fraction, this means that you have to use something called the conjugate. So complex numbers always come in pairs, and that conjugate is just switching the sign. So we're going to find the conjugate of these 3 imaginary numbers before we dive into multiplying by the conjugate. So the conjugate of 3 plus 4i should be 3 minus 4i. And then with negative 2 minus 3i, that should be negative 2 plus 3i. And then 4 plus negative 2i, we can simplify this to 4 minus 2i. But then that conjugate is going to be 4 plus 2i. So then for example 3, we will have 5i over 3 plus 2i, and we need to get it to simplest terms and get that I out of the denominator. So we're going to multiply by that conjugate over itself. So we will have 3 minus 2i over 3 minus 2i. And then we will need to multiply. So we will have 5i times 3 minus 2i. That is going to give us 15i minus 10i squared. And that will be over 3 times 3, which is 9. And then our outsides, which is minus 6i, our insides, which is plus 6i. So those two will cancel. And then 2i times negative 2i, which gives us a negative 4i squared. So then on top we have 15i minus 10i squared, so that becomes plus 10. Actually, I probably need to back up just a little bit because it's going to be minus 10 times negative 1 over, and then since our I terms canceled, we are left with 9 minus 4 times negative 1. And then we are going to simplify those things. So we have 15i plus 10 over 9 plus 4. And so that leaves us with 10 plus 15i over 13. So on example 4, we have 5 over negative 2 plus 4i. So we have negative 2 minus 4i over negative 2 minus 4i for those conjugates. And so when we multiply, this is going to give us a negative 10 minus 20i. And then we can multiply the denominators. So negative 2 times negative 2, which is a positive 4. And then my outside terms, we have plus 8i. Inside terms is negative 8i. And then our last terms, which is negative 16i squared. So there's nothing to simplify on the top this time. That's not always the case, of course, as you saw in the last problem, but it does happen. So we're just going to bring that numerator over. And then on the bottom, those 8i's wind up canceling out. And we have 4 minus 16 times negative 1. So we have negative 10 minus 20i over 4 plus 16, which is negative 10 minus 20i over 20. And then we can actually reduce all of this by 10. So that's going to give us negative 1 minus 2i over 2. All right, so on number 2 here, we've got a binomial over a binomial. So we are still going to multiply by that conjugate. So we have negative 10 minus 4i over negative 10 minus 4i. And so that leaves us with, let's see, I needed to FOIL on both top and bottom. So we have negative 7 times negative 10, and that gives us 70. And then our outside, we have a positive 28i. Our inside is a positive 90i. Then our last terms, we have a positive 36i squared. And that is going to be over a positive 100. Then we will have a positive 40i, a negative 40i, and then a negative 16i squared. So when we start combining like terms, we have 70 plus 118i plus 36 times negative 1. That is over 100. Those 40i's cancel. Minus 16 times negative 1. Then we have 70 plus 118i minus 36 over 100 plus 16. So then we have 70 minus 36. That is 34 plus 118i over 116. So we are almost done, but this can simplify actually by 2 at least. So we are going to simplify by 2. That gives us 17 plus 59i over 58. And that would be our final answer for it. So now on example 5, I want you to go ahead and pause the video and try this one out on your own. Remember to look for that binomial in the denominator, and if you have it, you need to multiply by the conjugate. So go ahead and work this one out and then hit play when you're done. Okay, so let's go ahead and see what we got. So we should have negative 4 minus 3i over itself to multiply by. So we have 2i times negative 4 minus 3i. And so that gives us a negative 8i minus 6i squared all over negative 4 times negative 4, which is 16. Then we have a positive 12i, and then a negative 12i, and then minus 9i squared. So we have negative 8i minus 6 times negative 1 over 16. The 12i's cancel. Minus 9 times negative 1. And then we have negative 8i plus 6 over 16 plus 9. And we have then negative 8i plus 6 over 25. And of course, we need to rearrange that just a little bit. 6 minus 8i over 25. That one will not reduce. So that is your final answer.